In this training session, we'll examine the landing gear, the braking system, and the steering system. The ATR has a retractable tricycle fuselage-mounted type landing gear. The main landing gear is an inboard retractable type, mounted partially below the passenger compartment floor and partially in a specific fairing in side pods. The nose landing gear is a forward retracting type, which fully retracts into a wheel well on the aircraft nose. When the landing gear is fully retracted, the doors restore the fuselage contour. Take a look at the table Maximum Landing Gear Extended or Operating Speeds. The right and left main landing gear each consist of a trunnion leg, a trailing arm, an oleo-pneumatic double-acting shock absorber, an actuator, and a locking and unlocking mechanism for the gear in the down position. When retracted, an up-lock box mechanically holds the main gear in the up position. In the event of an emergency extension, the gas actuator freefall assister installed in the trunnion assembly helps to fully extend the main landing gear. The main landing gear doors are composed of 3 panels attached to the trunnion leg, which are mechanically operated when the landing gear is extended or retracted. The nose landing gear is composed of a leg strut, a drag brace, it also incorporates a shock absorber, a steering feedback system, as well as the steering mechanism. When extended, a drag brace supports the landing gear and keeps it locked down. When retracted, an up-lock box mechanically holds the nose gear in the up position. The nose landing gear doors are composed of 4 panels that completely restore fuselage contour when in the retracted position. The doors are mechanically attached to the nose gear and actuate in conjunction during gear extension or retraction. In this lesson, we will review the controls and indicators of the ATR 72-500 landing gear system. The landing gear control panel is located on the main instrument panel. The control lever has 2 positions. Up is selected for landing gear retraction, and down for landing gear extension. A red light is also incorporated into the lever that will illuminate through the MFC whenever the gear is commanded down, and the crew alerting system detects that one of the landing gear is not sensed in the down and locked position. Now observe the 2 landing gear position indicators on the main instrument panel and on the overhead panel. A green indication will illuminate when the respective landing gear is in the down and locked position. A red unlock will illuminate when the control lever is selected down and the associated landing gear is not in the locked position. The red unlock will also illuminate when the airplane is on ground and the respective uplock box is not in the opened position. In this part, we'll see how the airplane determines the landing gear position and how it relates to the crew alerting computer and the pilots. The gear position and indication system is composed of 2 independent systems, the primary and the secondary systems. They receive dedicated segregated signals from the MFC system. The primary system is controlled by the MFC module 1A and displays the landing gear position on the main instrument panel. The secondary system is controlled by MFC Module 2A and displays the landing gear position on the overhead panel. The systems work independently, and each one uses its own detectors and indications, such as downlock and air-ground signal from the proximity switches, and uplock signals from the mechanical limit switches. Both systems are able to independently command gear extension and retraction, activate the gear anti-retraction system, and the warnings associated with a landing gear not down situation. If a landing gear leg is not down and locked with flaps set to 30 degrees and radio altimeter indication below 500 feet, or with at least one power lever at flight idle and radio altimeter indication below 500 feet, the MFC will activate the CCAS, and the following warnings will be triggered. The master warning light flashes red. The landing gear not down red light illuminates on the CAP. The red light in the landing gear lever illuminates, and the continuous repetitive chime is activated. Notes: in the first condition, depressing the master warning push button will not silence the continuous repetitive chime. In the second condition, the alerts are inhibited for 150 seconds after the retraction of at least one landing gear leg in case of the one-engine inoperative go-around. In both cases, the radio altitude is inhibited in case of radio altimeter failure. Note that whenever you operate the landing gear, you have to consider it down and locked as soon as one system indicates it down, 3 greens. The ATR 72 landing gear is hydraulically operated and normally supplied by the green hydraulic system. It can alternately be supplied by the blue hydraulic system if the green hydraulic system fails. During normal operation, retraction and extension of the landing gear can be achieved by the actuation of the landing gear control lever located on the main instrument panel. Placing the control lever in the up or down position gives an input to the MFC to electrically command the selector valve, which in turn positions the valve to the hydraulic extension or retraction line. The landing gear is prevented from retracting by an anti-retraction latch installed on the landing gear control lever and controlled by the MFC system. It's also prevented from retracting when the aircraft is on ground with at least one shock absorber compressed. Note that the landing gear will only retract when all 3 shock absorbers are fully extended. If the weight on wheels system doesn't recognize that the aircraft is in flight, the landing gear will not retract despite moving the landing gear lever to the up position. In this case, follow the applicable checklist in the QRH. Let's now look at the landing gear emergency extension system. It must be used whenever the normal system operation of the landing gear cannot be achieved. The system is intended only for extensions of the landing gear. In case of a total loss of hydraulics, the landing gear can be extended and locked down by gravity and aerodynamic forces. Full extension of the main landing gear legs is ensured by action of the freefall assisters, while a mechanical device assists the nose landing gear extension. The locks are secured by locking springs on each brace strut. Emergency landing gear extension is performed by pulling the emergency handle located in the cockpit in the aft portion of the center pedestal. Do not twist the handle when operating it. By cable action, the uplock box hooks open and the 3 landing gears are free to extend. A check valve in the green hydraulic return module allows hydraulic fluid suction from the hydraulic reservoir to prevent cavitation of the landing gear actuators. Please note that if you don't place the landing gear control lever in the down position, the unlock will illuminate on the associated landing gear panels. In this chapter, we'll have a close look at the braking system. Each of the ATR 72 main landing gear has 2 tubeless tire wheels. Each wheel is equipped with a multi-disc carbon brake actuated by a set of 5 pistons. Additionally, each brake assembly is fitted with an automatic adjuster mechanism that provides automatic compensation for the brake's wear, a wear indicator pen, and an overheat detector. The ATR 72 is fitted with carbon brakes to cope with higher masses. Pilots shall pay special attention to the correct operation of carbon brakes to avoid premature wear and high costs. Operational usage and life testing of carbon brakes has revealed that carbon brakes wear out at different rates than steel brakes. A rejected takeoff dumps massive heat energy into the brake and would be expected to be the worst case for brake wear. Carbon surprisingly shows much less wear than steel under these conditions. Furthermore, the amount of wear during each landing is extremely low, irrespective of energy input, and much lower than for steel brakes. But during normal taxi operations, the carbon brakes wear at a much higher rate when compared to steel brakes, especially when the carbon brake is cold. Therefore, any reduction in the number of brake applications during taxi will result in a significant increase in brake life. This can be achieved by using a small amount of reverse power when deceleration is needed. Remember that riding the brakes will adversely affect brake wear. A brake temperature indicator is installed in the main instrument panel. If at least one of the brake temperature sensors detects a temperature higher than 150 degrees Celsius, the amber hot local alert will illuminate. The amber master caution lights will flash. The wheel's amber caution on the CAP will illuminate, and a single chime will be generated. In the event of a brake overheat and to prevent tire burst, each wheel is equipped with fusible plugs. When the temperature on the plugs reaches 177 degrees Celsius, that is 350 degrees Fahrenheit, the tires will deflate. The ATR 72 has two modes for braking the aircraft: the normal mode and the emergency and parking brake mode. The normal mode is supplied by the green hydraulic system and is actuated by the pilot's brake pedals. Once pressure is applied to the brake pedals, hydraulic fluid from the green system is metered and sent to the anti-skid system that will further control the pressure on the brakes, preventing them from locking the wheels. The blue hydraulic system normally provides fluid under pressure from the blue hydraulic pump. Additionally, the DC auxiliary hydraulic pump or the brake accumulator is used to supply hydraulic power to the system in case the respective blue hydraulic pump is de-energized or fails. The brake pressure indicator is located in the main instrument panel. It displays the pressure in the brake accumulator if the pressure is higher than 1,600 psi. The actual pressure is indicated in psi times 1,000, and the normal value is 3,000 psi. If the green hydraulic pressure is lost, the normal braking system becomes inoperative. In this case, or when parking the airplane, the emergency parking brake mode, which is supplied by the blue hydraulic system, shall be used in order to brake or park the airplane. In the event that the green and the blue hydraulic system's power are lost, the system will operate by using the brake accumulator pressure that allows at least 6 braking applications. The emergency and parking brake system is mechanically actuated by pulling the emergency parking brake handle located in the forward left side of the center pedestal. The emergency parking brake handle has 2 notch positions: the parking and the emergency notch position. The handle is spring-loaded to position off if not properly set into one of the 2 notch positions. When the emergency parking brake handle is not fully in the off position, the amber parking brake caution light on the CAP will illuminate. This indication is taken into account by the takeoff configuration warning system but not by the takeoff configuration test. If a takeoff is attempted without fully releasing the emergency parking brake handle to the off position, the red config warning will illuminate on the CAP, and the CCAS will activate the master warning flashing light and the continuous repetitive chime. Let's see the parking brake actuation. With the airplane stopped, the pilots actuate the emergency parking brake handle rearwards to the parking notch. This action will allow full hydraulic pressure to be applied to the brakes. The emergency brake operates in the same way as the parking brake. The pilot has to move the emergency parking brake handle rearwards from the off position to the emergency notch. The use of the emergency brake notch during a rejected takeoff or at touchdown gives repeatable and smooth deceleration, minimizing the risk of exploding the tires. Using the emergency brake beyond the notch with speeds above 60 knots may cause the wheels to lock up and may damage wheels and tires. Below 60 knots, a movement of about 1 centimeter beyond the notch may be used without risk of damage, and should be used only when maximum stopping power is necessary. A takeoff shall not be attempted after the emergency brake has been used at speeds above 20 knots without prior visual inspection of the tires. The anti-skid system will be presented in more detail in the following lessons. The purpose of the anti-skid system is to increase the braking action, to prevent the main gear wheels from locking, and to produce maximum braking effectiveness. The anti-skid system is available when the landing gear is down and locked, and the wheel speed is above 10 knots. The system monitors each wheel and each pair of external and internal wheels. When using the emergency parking brake mode, the anti-skid system is not available, and all protections are lost. The anti-skid system provides touchdown and locked wheel protection. The touchdown protection prevents braking action at touchdown for 5 seconds, or when wheels reach a speed of 35 knots. The locked wheel protection compares the right and left inboard wheels and the right and left outboard wheels. This protection is available with a wheel speed above 23 knots. When a wheel is sensed to have a differential of 50% or more in the speed compared to the paired one, the braking pressure on the slower wheel is reduced, allowing it to regain speed. The locked wheel protection functions to avoid tire scuffing on the runway surface. The anti-skid panel is located in the main instrument panel and is composed of the anti-skid push button, 4 anti-skid channel fault lights, and a test push button. The anti-skid push button controls the activation and deactivation of the anti-skid system. With the push button depressed, the system is activated and no light is displayed. When pushed out, a white off light will illuminate, indicating that the anti-skid system has been deactivated. The anti-skid channel fault lights illuminate amber, followed by the CCAS activation in case of a channel failure. The light corresponds to the wheel that has lost the anti-skid capability. By pressing the test push button, an automatic test is initiated on the system. This test can be performed on ground or in flight. On ground, the test takes about 6 seconds to be completed, while in flight it takes about 3 seconds. During the test, the anti-skid channel fault lights will illuminate, and if a channel fails, the associated channel light will remain on. If performed on ground with the brake pedals depressed, the test allows the observation of the brake compression and release. Note: the test shall not be performed on ground with engines running unless the parking brake is set. Also, the test function is inhibited on ground with speeds exceeding 17 knots. The anti-skid module receives the green hydraulic system pressure from the left and right sides of the brake metering valve. The amount of hydraulic pressure released by the metering valve depends on the pressure applied on the pilot's brake pedals. Each wheel has a speed sensor that measures the actual wheel speed and sends this information to the anti-skid control box that also receives the actual airplane velocity. Based on this information, the output pressure to each wheel is regulated by the anti-skid control module in order to provide efficient braking regardless of the actual runway surface conditions, thus minimizing wheel slip, brake wear, and tire wear. During this process, if one wheel decelerates in comparison to the other wheels, the hydraulic output pressure to that wheel is reduced in order to allow it to have the same velocity as the others. If electrical power to the anti-skid system is not available, the system becomes inoperative and the brakes are operated in direct relation to the pressure applied to the pilot's brake pedals. Note: all protection is lost. The ATR 72 steering system permits the nose gear wheels to be turned during airplane ground maneuvers. The system is controlled by means of a hand wheel located on the captain's left side console. Only one hand wheel is installed. The blue hydraulic system powers the steering system. With the blue hydraulic system operative, by actuating the hand wheel, a mechanical command is sent to the steering control unit to allow the passage of hydraulic fluid to the steering actuator in order to move the nose wheels in the desired direction. During a turn, when maximum angle is reached, a feedback mechanism cancels the pilot input on the steering control unit to avoid damage to this system. With hydraulic pressure applied to the system, a maximum 60-degree angle left or right from center can be obtained. At high speeds, an anti-shimmy function ensures a damping action to keep the nose gear wheels aligned, and after liftoff, an internal mechanism returns the wheels to the centered position. Let's assume the airplane is in flight during a normal approach. As soon as the nose landing gear is extended and locked in down position, the swivel valve opens. Cams located in the nose landing gear leg center the nose wheels. After touchdown and with all shock absorbers compressed, a signal is sent to the solenoid valve, which allows the passage of the hydraulic fluid to the steering control unit in order to enable the airplane direction control on the ground by the handwheel steering. During the landing run, a feedback mechanism keeps the nose wheels within the selected position, avoiding deviations due to external inputs such as imperfections on the runway or foreign objects. During towing and without hydraulic pressure applied to the steering system, a deflection angle of up to 91 degrees can be achieved. Note that towing with tow barless system is prohibited. Do not perform pivoting, sharp turns on a landing gear with fully braked wheels, except in case of emergency. The nose wheel steering switch is located on the captain's left side console. This switch activates and deactivates the steering system. Normally, the switch is guarded in the on position, meaning that the solenoid valve is electrically armed. Once the steering control handwheel is operated, the nose wheels will move in the desired direction. The switch can be moved to off by raising the guard and flipping the switch to the off position. This will de-energize the solenoid valve and depressurize the steering system. In case the nose wheel steering switch is set to the off position, or if the blue hydraulic pressure fails, the aircraft's direction can be controlled on the ground by applying differential power to the engines and by using a differential braking technique. In this case, both engines must be running and sharp turns shall be avoided, since the turn radius should be limited to half of the normal value. On the right side maintenance panel, a Wait on Wheels switch is installed for maintenance purposes only. The mode selector has a guard and is normally placed to the normal position, thus allowing the system to work normally. Raising the guard and placing the selector to the flight position, all systems requiring information from the Wait on Wheels system are set to the in-flight position, and the amber maintenance panel light on the CAP will illuminate.